In this segment, we will look at the factoring of trinomials of the form ax squared plus bx plus c, where the leading coefficient is not 1. We know how to multiply two binomials together. In fact, many of us refer to the process of FOIL when keeping ourselves organized in doing this. So just to review this, because I'm going to show you a different way to multiply binomials in a minute. We go the first two terms multiplied to give us 6x squared. The outside term, 10x, combined with the inside term, multiplied 3x, and the last term, 5, gives us a result of 6x squared plus 13x plus 5. All right, I'm going to show you a vertical method for multiplying binomials that will be handy when we begin factoring these trinomials. This time I'm going to set up my binomials as follows: 2x and 1 on the top, and in sort of a table format, the lower, or the second factor in the lower part of the table, 3x and 5. Now what I'm going to do to multiply is I'm going to multiply first of all the columns together to give me 6x squared. This column together to give me 5. And then in order to get the middle term, which we know is the combination of two terms, I'm going to take the cross product, 2x and 5, 3x and 1, 3x, adding these two together to give us plus 13x. Let's just try one more example with the vertical method of multiplication. Let's use 4x plus 3 multiplied by 6x minus 7. So once again, to multiply through the vertical method, we will set our terms up as follows. Be sure to have your negative sign in place on the 7. And then we will multiply this column to get the last term, this column. And to get the middle term, we will take the cross product of this diagonal multiplying to negative 28x, and this diagonal multiplying to 18x, and the two of them combining to give us negative 10. We have successfully multiplied our two binomials through vertical multiplication. So let's begin with some simple examples to show how we can use vertical multiplication to reverse the multiplication process back towards factored form. So let's begin by factoring 2x squared plus 5x plus 3. And as we know, that is going to result in the multiplication of two binomials. I'm going to set this up through my vertical method. So what two things will multiply to give us 2x squared? Well, 2x and x will. To give us the final term, we need two numbers that multiply to give us 3. Now, there are two orders in which these can come. We could have 3 and 1. The other option would be we could have 1 and 3. Now, what we need to do, of course, is we need to make sure that our cross products will multiply and combine to give us 5x. Our first option, this multiplied by 1 is 2x. This is 3x. And the combination of these two is 5x. This appears to be the right combination. You'll notice that in our second option, the cross product of 6x and the cross product of 1x would give us a combined middle term of 7x, which is not going to work. So therefore, it's our first option that's the one that's going to satisfy our factors being specifically 2x and 3, that would be plus, so 2x plus 3, and our second factor being x plus 1. It takes a few examples to catch on to this type of factoring. Let's try a few more. 2x squared plus 7x plus 6. So once again, we're expecting this to likely break down as the product of two binomials. What do our first two terms have to be? Once again, there is only one option for this. There's only two things that multiply to 2x squared. That would be 2x and x. Let's look at the options for the end of the polynomial. What two numbers multiply to give us 6? Well, actually quite a few. There are quite a few numbers that multiply to give us that. So let's start by trying a few of these. Let's just list them quickly. 6 and 1, 1 and 6, 2 and 3, and 3 and 2. These are all the possibilities for numbers that multiply to 6. Okay? Now what we need to do is we need to test each of these options individually in our vertical array. So let's place 6 and 1 here. What we're testing, of course, is whether the cross product of these two diagonals will add together to give us 7. 2x and 6x doesn't add or subtract to give us 7. So that option is out. Okay? Let's try, let's just write this again. 2x and x. Let's try 1 and 6. That would be 12 and 1. Does 12 and 1 add or subtract to 7? No, it doesn't. So that option is also out. What about 2 and 3? The cross product would be 6 and 2. That would add or subtract to 8. So we cross this one out. What about 3 and 2? The cross product is 4. The cross product is 3. And those two add or subtract to 7x. So our factors must be 2x plus 3 and x plus 2. Question 3. 3x squared minus 14x plus 8. If you would like to take a minute to try this on your own before continuing with the video, feel free to pause the video for a moment. We're expecting this to break down as the product of two binomials. We're looking for two numbers that multiply to 3x squared. Easy enough, 3x and x. We're looking for numbers that multiply to give us 8. Again, there are many options. 1 and 8, 8 and 1, 2 and 4, and 4 and 2. We now need to test each of these options out. So let's try 1 and 8. Cross product is 24 and 1. That does not add or subtract to 14. That option does not work. Let's try 8 and 1. The cross product is 3 and 8, which does not add or subtract to 11. So that option is out. Let's try 2 and 4. The cross product is 12 and 2. Well, that would be 14 if we had some negatives involved. So let's see if we can make this work. All right, does our cross product work now? Negative 12x minus 2x is negative 14x. That does in fact work. So our two binomials would be 3x minus 2, x minus 4. Question 4. Factor 4x squared plus 19x minus 5. Once again, we're looking for two numbers here that multiply to 4x squared. Now this time there would be more than one option. There might be 4x and x, but there might also be 2x and 2x. For the back, it's 5 and 1, or 1 and 5. So what we need to do is we need to test these two options in each of these two options to find the possibility that we'll give these two binomials, multiply these two binomials back to this trinomial. Let's begin. Let's try 5 and 1. Maybe we'll get lucky early. Cross product is 4, cross product is 5, that's 9, that doesn't work. Okay, so that option is then out. Let's try 1 and 5. This is 20, this is 1, that adds or subtracts to 19. This might be the possibility that we're looking for. Now, in order for these two numbers to multiply to -5, one of these numbers would have to be negative. And in order for these two numbers to give us 19, the larger one will need to be positive and the smaller one will be negative. Putting all that information together, that would mean that our negative would have to be here and our positive here. Notice how this is 20x and how this is negative x and how the combination of those two is negative 19x. So our two binomials will be 4x minus 1, x plus 5. Our final question is to factor 4x squared minus 16x plus 15. Once again, this is a more difficult question because for the front, we have two possibilities. We have 4x times x, but perhaps the front will also be 2x times 2x. Further complicating this is the fact that the back part of the polynomial, the last two numbers in the factors, could be factors of 15, which are 1 and 15, 15 and 1, 3 and 5, 5 and 3. 1 and 15, 60 and 1, that's not going to combine to give us that. 15 and 1, cross product is 15 and 4, 19, that does not give us 16. 3 and 5, cross product is 20 and 3, that adds or subtracts to 17 or 23. That does not work. And our last possibility for the top alternative is to try 5 and 3. This cross product is 12, this cross product is 5. That does not add or subtract to 16 either. So it looks as though this option is out. Let's try the bottom. 2x and 2x, 1 and 15. Our cross product is 30 and 2. That does not add or subtract to 16. Let's try 15 and 1. Cross product is 30 and 2, does not add or subtract to 16. Next possibility, 3 and 5. Finally, I see it coming. 10x and 6x is giving us 16. All right, now we need to fix up the signs to make them work. If this was negative and this was negative, we would have negative 10 minus 6, which would be negative 16, and these two terms here would multiply to 15. And so after a lot of work, but work that will eventually lead to a successful result, if there is one, we have 2x minus 3 as one factor and 2x minus 5 as another factor. Factoring these trinomials with a leading coefficient not 1, does take some time, but this procedure I think you will find to be reliable and a successful way to factor polynomials of this type. Good luck.